Good morning, everyone. My name is Nguyen. Today, I'm thrilled to discuss with you the advantages of ontologies for data catalog and data analysis. Before I am going to the details, I would like to discuss the problems data silos. Imagine that you are the owner of a company with many datasets. Your employees cannot see all available data. This situation is referred to as data silos. Data silos emerge when several groups of employees work with their own data and unaware of other available data in their company. The data silo state is a root cause of many problems such as search for data, search in data that data catalogs address and ultimately solve. So you might wonder, what is a data catalog? A data catalog is a database with metadata about your data sources and data services. It has three key features. It creates an overview of the available data in your organizations. It organizes your data, and it allows you to search for your data. Before I am going to explain the data catalog vocabulary, I would like to give a brief discussion about an ontology. An ontology is a formal, explicit specification of a shared conceptualization. It is used to represent knowledge. An ontology can capture concepts, their properties, and relationships among them. It can perform reasoning. We can use its vocabulary to build knowledge bases. One example of using ontology for improving data catalog is using Data Catalog Vocabulary version 3. It was developed by W3C. It allows a publisher to describe datasets and data services by using a standard model and vocabulary. This data catalog vocabulary is designed to facilitate interoperability between data catalogs because all data catalogs use the same standard vocabulary. On the left side, we have vocabularies to describe a data catalog. On the right side, we have an example of a data catalog descriptions. In this case, we use the standard vocabulary to describe the data catalog. It has titles in different languages and several other attributes and datasets associated with the data catalog. With the metadata information, we can use it to search for our data sources and also for our data services. In this slide, we examine the differences between an organization with and without data catalog. As you can see, on the left side, we have an organization with data catalogs. Employees can use data catalogs to find data resources and services. And on the right side, we have an organization without data catalogs. Employees cannot search for data sources because they don't know much about the available datasets. It depends on the goals of the data catalog. We can have additional metadata. We can have metadata about data governance, data provenance, and lineage, and data lifecycle. As you can see, metadata allows a data catalog to fulfill its goals, such as creating an overview of available data, organizing available data, and allowing users to search their data with data governance, data provenance, and data life cycle. In this slide, we examine the WOW datasets. WOW datasets have their category change over the years. So if we examine category in year 2009 and 2019, we see that the meaning of the cattle category has changed. In 2009, we have only one category. However, in 2019, we have four categories associated with cattle. In other words, the meaning of the cattle category is not the same if we compare cattle information from year 2009 with 2019. There are many ways to improve data analysis with ontologies. One way to improve data analysis is to create equivalent cattle classes with year 2009 and 2019 so that we can compare them. So on the left side, we have species of our dataset that are documented for year 2009 and 19. On the right side, we can use ontologies to create the defined classes for year 2009 and 2019. For year 2009, it has only one cattle species. However, in year 2019, it is a combination of adult beef cattle, adult dairy cattle, and male and female cattle. So we can use the defined classes to infer equivalent classes between the year 2009 and 2019. So as you can see with my pointer on the right side, the class 2009 cattle and OIE cattle 2019 is equivalent classes. In addition to improve data analysis, we can also use ontology to improve data collection from users. We use SECO language. SECO is a shape constraint language. It was developed by W3C. It has well-defined constraint property for data input and data validation. It has some vocabulary that can be used to create form automatically, such as SH order and SH group. Here is an example of using SECO. We developed a web application. We can upload the SECO file. Our system will generate the input form automatically. In this slide, we have a form that generated based on the previous SECO file. So let's examine some information about the SECO form definitions. We can use the SH name to specify the country name, as you can see on the right, and also the SHN to create the drop-down menu. Similarly, we can do the same for species name, for example, and the drop-down menu for the species. For the species population, we can link the input box to the integers, and also we can create the constraint min inclusive 1, meaning that the field have to be greater than 1 or equal to 1. In this slide, we show that we can use the constraint to validate user input. In this case, if the user input for the species population is negative, then it gives you the errors. We discuss how ontologies can be used to improve search for data in a data catalog and improve data analysis. We can leverage the power of SECO to facilitate us in creating input forms for data collection and data validations. With standard vocabularies, search across multiple data catalogs can be achieved. It has a great implication for system scalability that involves with large number of datasets. Thank you so much for listening to my presentation. You have a good day. Take care.